In this lesson, we're going to look at joint cases, closure, inverse, commutative, associative, distributive, and identity property. So a binary operation is defined on the set R of real numbers by x operation y. X is equal to x plus y minus 2xy, where x, y belong to R. A, determine whether or not the operation is commutative. B, find the identity element of R under the operation. Find the inverse of the general element P, where P belongs to R. D, find the element of R under the operation that has no inverse. E, calculates 7 minus 5 root 2 operation 10 plus 7 root 2, giving your answer in the form A plus B root 2, where A, B are rational numbers. The rule of combination is x operation y equals to x plus y minus 2xy. So A, for commutativity, x operation y should or must be equal to y operation x. And here x operation y is given as x plus y minus 2xy. So what is y operation x? That will give us y plus x minus 2yx. When we arrange the letters alphabetically, we are going to have x plus y minus 2xy. So this is same thing as this part, which is x operation y. That is equal to x operation y. So therefore, since x operation y is equal to y operation x, it follows that the operation is commutative. Operation is commutative. B, find the identity element of R under the operation. So let the identity elements be E. So look for the identity elements under R. So that will give us x operation E is equal to x plus E minus 2xe. So but x operation E is equal to x. We'll put this in place of this here. So x equal to x plus E minus 2xe. So we're going to use one here. X minus x is equal to E minus 2x. 0 is equal to E 1 minus 2x. Yes, x E 1 minus 2x. So dividing both sides by 1 minus 2x, we have E is equal to 0 over 1 minus 2x, and of course E is equal to 0. So therefore the identity element is 0. C, find the inverse of a general element P, where P belongs to R. So to find the inverse P, for inverse, since the question said we should find the inverse of a general element P, P also belonging to the set R of real numbers, that means P operation P inverse should be equal to what? Identity. So from our general equation where we have x operation y, so P would be replaced x would be replaced by P, and y would be replaced by P inverse. So this relation will soon be affected soon. So P plus P inverse minus 2P inverse equal to E, and E is 0. So this will give us P will move to this side, so P inverse minus 2P P inverse is equal to 0 minus P. So we'll come over to this part of the board. P inverse minus 2 P inverse equals to minus P. So factor P inverse out. P inverse equals to 1 minus 2P, which is equal to minus P. So we divide through by 1 minus 2P. That will give us P inverse equals to minus P over 1 minus 2P as the inverse of P. So therefore, the inverse of element P is minus P over 1 minus 2P. Find the element of R under the operation that has no inverse. For the element under R, elements under R to not have inverse implies that we need to get the value for which the inverse, for which P inverse is undefined. So that means that is the denominator is equal to 0. So for us to find the element of R under the operation that has an inverse. For it to not have inverse, it implies that P inverse is going to be undefined. And for it to be undefined, the denominator must be equal to 0. So for that condition, 1 minus 2P is equal to 0. So we bring minus 2P to this side, 1 is equal to 2P, and then P is equal to half. So P must have this value for this inverse for this P not to have inverse, because once P is 1 over 2 here and this is equal to 0, minus P over P here, which is half over 0, will be 0, so there will be no inverse here. So here's your answer. E. So we're to simplify this operation, and once we simplify this, we're going to get to this form. So let's first of all write our general rule. X operation y is equal to x plus y minus 2xy, and here we have 7 minus 5 root 2 operation 10 plus 7 root 2. So here 7 minus 5 root 2 is x, 10 plus 7 root 2 is y. So this will give us for here x is 7 minus 5 root 2 plus y is 10 plus 7 root 2 minus 2, and x is 7 minus 5 root 2 bracket y 10 plus 7 root 2. So let's open 7 minus 5 minus 5 root 2 plus 10 plus 7 root 2 minus 2. 7 times 10 is 70. 7 times 7 is 49. That's plus 49 root 2. Minus 5 times 10 is minus 50 root 2. Minus 5 times plus 7 has 35. Minus 35. Root 2 times root 2 is 2. So minus 35 times all bracket closed. So here 7 plus 10 is 17. minus 5 root 2 plus 7 root 2 will give us plus 2 root 2. So we are done with this part, minus 2. Let's simplify here. 70. Okay. Now here we have 49 root 2 minus 50 root 2. That's minus root 2. Minus 35 times 2 gives minus 70. So plus 70 minus 70 will cancel out. And here plus 49 root 2 minus 50 root 2 will give us minus root 2. Minus root 2. Also 17 plus 2 root 2 minus 2 times minus root 2 will give us plus 2 root 2. So 2 root 2 plus 2 root 2 will give us 17 plus 4 root 2. And when the question says final answer for this signification of this expression should be left in this form, a plus b root 2. So now let's find our a. Therefore, a from here is 17, which is a here 17, and b is equal to what? 4. So our final answer is 70 plus 4 root 2. A binary operation is defined on R, the set of real numbers, by x operation y is equal to xy over 4 plus x plus y for all x and y members of R. A, find one identity element. So A, I, let the identity elements be E. Let the identity elements be E. So if x star y is equal to xy over 4 plus x plus y, then x operation E, which is the next element replacing y, which equals x e over 4 plus x plus e. So both x operation E is equal to what? X. So x is equal to x e over 4 plus x plus e. Now cross multiply both sides by 4. So then we need to know. Okay, so we're going to move x to this side. So x minus x plus the x e over 4 plus e. Here is 0, and this will give us LCM. Here is 4. This is x e plus 4e. So we cross multiply both sides. Cross multiply. So 0 times 4 will be 0. Equal to x e plus 4e. And 0 is equal to e. X plus 4. Then divide through by x plus 4. We're going to have e is equal to 0 over x plus 4. Therefore, the identity element e is what? 0 divided by x over 4 is 0. The identity element is 0. Now figure 2. Find the inverse of an element R. So for inverse of R, that means R operation. First of all, for inverse of R, since x operation y is equal to x y over 4 plus x plus y. So for inverse of R, x will be replaced by R and y will be replaced by R. Inverse of R, which is R operation R raised to power 1. This will give us x is R, so R minus 1 over 4 plus R plus R minus 1. So but inverse but R operation R is equal to E, where E is equal to 0 from here. If we're not told to look for E and we are told to look for inverse, that means first of all we would have to get the value of the inverse. But now the first question was that we should get the identity element E. So we've gotten it, which is 0. So we're going to put it here. So 0 R operation R inverse is equal to E. So E is equal to 0. So 0 is equal to r. So 0 is equal to r inverse over 4 plus r inverse. So what we need to take away from here is r. So 0 minus r is equal to r inverse plus r inverse. And here, remember this is 4. So our LCM 0 minus r is equal to, LCM here is 4. 4 r inverse plus 4r inverse. So cross multiply. So 4 cosine 0 minus r is equal to r inverse plus 4r inverse. So 4 times 0 is 0. 4 times r is r, which is equal to factor r inverse out. R plus 4. Okay, so now we have minus 4r is equal to r inverse r plus 4. Next thing to divide both sides. Divide through by r plus 4. And that will give us r inverse is equal to minus 4r over r plus 4. So that's our inverse r plus 4. This is solve the equation x plus 6 is equal to 36. We compared this to general binary rule. X star y is equal to x over xy over 4 plus x plus y. So x here is x and 6 is y. So in this equation, this part of the equation, wherever we have x, we put our x there, and our y will become 6. So and x star 6 is equal to 36. So x y, so x times 6 over 4 plus x plus 6 is equal to 36. So 6x over 4 plus x plus 6 is equal to 36. So what do? We take to this side. 6x over 4 plus x is equal to 36 minus 6. Now we look for LCM. Here LCM is 4. 6x plus 4x, and this is 30 over 1. Cross multiply. So 6x plus 4x times 1. Everything here times 1 is still the same thing. Then 4 times 30 should be 120. Then we can factor out 2x. Yeah. No, okay. 6x plus 4 is 10x. That's 120. So divide through by 10. Divide through by 10. So 10x over 10, 120 over 10. 10 here 1, 10 here 1, 10 here 1, 10 here 12. So therefore, x is equal to 12. So which means that 12 star 6 will give us 36. An operation is defined by x star y is equal to log y to base x. So let's evaluate the following. A operation, before we start off, let's write our mean. X star y is equal to log y to base x. So A. So 2 operations is, so where 2 is equal to x is equal to 2 and y is equal to 8. So that will give us log 2 8. So let's simplify. This is equal to log 2 raised to the power of 2, and that will give us, from our laws of logarithm, this power will come over to the side to give us 3 log 2. So the logarithm of a number to that base will give you 1. So that means logarithm of a to base a will give you 1. So is equal to 1. So this is equivalent to 3 times 1, which was 3 times 1. So logarithm of 2 to base 2 will give you 1, and that's equal to 3. B. 3 operation is 1 as log 3 is 1, which can be simplified to logarithm of 3 to the power of 4. 3 times 2 is 9, 9 times 3 is 27, 7 times 2 is 8, so 1, so raised to the power of 4, which is equal to 4 log 3, 3. And of course, since this part is 1, cancel the 4. So 5 star 25 is equal to log 5 25. That's equal to log 5, 5 is power 2. That's 2 log 5, and that's equal to 2. Okay. 10 operation 0.0001. That's equal to log 10 raised to minus 4. And this will give us minus 4 log 10 to base 10. That is minus 4. Because log of 10 to base 10 is 1. So it's minus 4. E. Let's go here. E. 1 x operation 1. X operation 1 log x 1. This is equal to log x is equal to 0. From logarithm or from indices, 1 is equal to x is equal to 0. So that will give us 0 log x. So log of x to base x is 1. So 0 times 1 is equal to 0. And then f. For f, we have x operation x, that's log x. Log of x to x. And of course, log of x log as x raised to power 1. Then it's raised to x raised to power 1 is equal to x for indices. So this will give us 1 log x. So this equals to 1. Since log x, log of x to x is 1. 1 times 1 is 1. Yes. So the next part, simplify x star. So to simplify x star. So we're going to simplify this part first of all. This will give us x star. Now x star x is equal to log of x to x, and that will give us x star log x raised to the power 1. That's log x star 1 log x. Log of x to x is 1. 1 times 1 is 1. So eventually it will give us x star 1. And x star 1 is equal to log, let me write it here, equal to x star 1. And x star 1, so x star 1 is equal to log x 1. Why is it 1? That is x raised to 1 is equal to x raised to the power 0. And that will give us x raised to the power 0 is equal to 0 log x. Logging of x to x is 1. 1 times 0 is 0. So the final answer is 0. So operation x star y x star y is equal to 3x plus x over y. So e and to solve for x star 3, x star 2 is equal to 20. X star 3 means that y is still with x. So that's 3x plus x over 3 is equal to 20. X over 1. LCM is 3, 9x plus x to 20 over 1. Cross multiply 9x plus x equal to 3 times 20. So 10x equal to 60. And x is a 60 over 10. 10 here 1, 10 here 6. So x is equal to 6. The x operation 2 is equal to 28. So 3x plus x over 2 is equal to 28. So LCM is 2. 2 into 1 is 2. 2 times 3x, 6x. 2 into 2, 1. 1 times x is x. 28 over 1. And you cross multiply, you have 6x plus x 28 times 2. So 7x equals to 2 times 8, 16. 2 times 2, 4 plus 1, 56. X equals to 56 over 7. And x equals to 8. C. X operation x is equal to 22. So this means that x here is x and y here is also x. So that will give us 3x plus x over x. That's equal to 22. So x over x is equal to 1. 3x plus 1. X here 1, x here 1. So 1 divided by 1 is 1. Equal to 22. 3x equal to 22 minus 1. 3x equal to 21. And x is equal to 21 over 2. 2 here 1, 2 here 7. So therefore x is equal to 7. So let's write down our operation x operation y is equal to x raised to y. So a 2 operation x. 2 operation x is equal to where x is 2 and y is x. 2 raised to what? 2 raised to x. The 4 operation x is equal to 4 raised to x and is equal to 2 raised to the power of 2 over x, and that's equal to 2 raised to 2x. That means we simplified 4 with this, so the simplest form it can be by raising to power 2 that is 4 is equivalent to 2 raised to the power of 2, and 2 times x equals to 2 x, which is 2 raised to the power of 2x. C equals to 8 operation x. 8 operation x is 8 raised to the power of x, and this will give us 2 raised to the power of 3 x. That's got 2 is 3x. And D 16 operation x. 16 operation x equals to 16 raised to the power of x, and that's equal to 2 raised to the power of 4. All raised to x is equal to 2 raised to the power of 4x. And hence or otherwise show that 2p 2 raised to the power of p 2p operation x is equal to 2px. Let's show the 2p operation x from our general operation. Okay, let's say we want to prove this. So it's an adjoint operation x star y is equal to x raised to y. So here 2p is x and x is y. So x, so therefore 2p operation x is equal to, where our x is 2p, so 2 raised to the power of p, and then x is y, so raised to x times x, and this will give us equal to 2px, which is what we have here as the proof. A binary operation star is defined on the set R of real numbers by x star 1, x star y is equal to x plus y plus 2xy, 3xy. So determine whether or not star is a commutative. For star to be commutative, that means x operation y is equal to y operation x must be equal to x operation y is equal to x plus y plus 3xy, and then y operation x is equal to y plus x plus 3yx, and this is also equal to x plus y plus 3xy, and this is just what x operation y is. So we say since x operation y is equal to y operation x, then star is commutative. Then star is commutative. Then for star to be associative, means x star y, x star y star z. Let's say it's also a number of the set R is equal to x star y star z. So let's work on this part first of all. Remember that x star y is x plus y. X star y is x plus y plus 3xy star z. This will give us, so this everything inside this bracket is x from the general rule, and then y is z. So we are going to use this to prove that star is either associative or not associative. So x is what we have here, y is z. So from here we have this is equal to x plus y plus 3xy, then plus y, which is plus z, then plus 3x 3xy, and I said that y is z, so 3z, then x is going to be this part, so x plus y plus 3xy. Let's open. Now x plus y plus 3xy plus z plus 3z times x, that's 3xz plus 3z times y, that's 3yz plus 3z times 3xy, that's 9xyz. Let's see if we can add up like terms. We have 3xy, 3xz, 3yz. So they are not like terms, so this will be equal to x plus y plus z plus 3xy plus 3xz plus 3yz plus 9xyz. So let's work on this part. So now next, so we should have said first evaluate x star y star z. So next evaluate x star y star z. Now y star z but y star z is equal to, when compared to the general equation, x is y and y is z. So this will give us y plus z plus 3yz. So x star y star z is equal to x star y plus z plus 3yz, where our x here from our general rule of combination is x and our y is this whole bracket. So let's continue. So this is equal to x plus y is y plus z plus 3yz, then plus 3. So here, remember y is the 3xy. So x, our y is z. So our y is y star z from the general equation. Y is bracket. So 3x here, since it's 3xy, and then brackets follow y plus z plus 3yz. So let's open our bracket. X plus y plus z plus 3yz plus 3xy plus 2xz plus 9xyz. Now let's x plus y plus z plus 3xy plus 3xz plus 2yz plus 9xyz. Okay, now let's compare this function x operation y operation z. Is it equal to the same function? Let's see. X plus y plus z, x plus y plus z, 3xy, 3xy, 3xz, 3xz, 3yz, 3yz, 9xyz, 9xyz. So what do we say? So since x star y star z is equal to x star y star z, star is associative. A binary operation star is defined on the set R of real numbers by x operation y. X operation y is equal to x squared plus y squared plus xy plus xy. So I by 2 operation 2. 2 operation 3 will give us 2 squared plus 3 squared plus 2 3. 2 3. 4 plus 9 plus 2 times 2 6. 4 plus 9 is 13. 13 plus 6 is 19. And then I 2 operation 3, 2 operation 3, operation 4. And this will give us 2 operation 3 is 2 squared plus 3 squared plus 2 3 operation 4. So 2 4 plus 9 plus 2 times 3 6 operation 4. 4 plus 9 13 plus 6 19 operation 4. This will give us 19 squared plus 4 squared plus 19 and 4. Nineteen squared 361 plus 16 plus 76. And this will give us 453. 453. Let's get order and I. So 2 star, 2 star, 3 star, 4. Equal to 2 star, 3 squared plus 4 squared plus 3, 4. And this gives us 2 star, 3 squared is 9, 4 squared is 16, plus 3 times 4, 12. That's 2 star, 9 plus 16 plus 12, 37. 2 star 37. This will be 2 squared plus 37 squared plus 2 37. This is our general rule here, x operation y. So 2 operation 37, we follow this rule. And this is equal to 2 squared is 4, 37 squared, which is it? 1369, 1369 plus 2 times 37, 74. 74 plus 1369 plus 4, 1447, 1447. This is to show that star is commutative but not associative. So for star to be commutative, or star to be commutative, that means x operation y should be equal to y operation x. X operation y is equal to x squared plus y squared. X squared plus y squared plus xy. And y operation x, y squared plus x squared plus yx. X squared plus y squared plus xy, which is equal to x operation y. Since x operation y is equal to y operation x, star is commutative. Star is commutative. So let's call this I for star to be associative. For star to be associative, it means x star y star z is equal to x star y star z. So x star y first evaluate x star y star z. So x star y star z is equal to x star y is equal to x squared plus y squared plus x y star z. So now our general equation, our general rule of combination, x is this bracket and y is this z. So in this equation, x equals bracket and y equals z. So this is the equation. So x here, x operation z will give us x squared. So this is x squared plus y. Everything here is x rather plus xy. And remember that it's squared, so square here plus, so y is z squared, then plus x again xy. So since y is z and x constants, I'll put my z here, z first, then x squared plus y squared plus xy. So let me open my bracket. This will be 1 x squared plus y squared plus xy squared. So okay, I will leave it like this. I don't want to open it. So that's, I just leave it like this. Z squared plus z x squared x squared plus y squared plus xy. You may decide to open it so you can get the expanded form of uh, this expression and then correct items. But we decide to leave it like this. Then we move to the next one. So next evaluate y x star y star z. So x star y star z is equal to x star. Now y star z will take the place of this expression. So here will be y and this will be z. So now we give us y squared plus z squared plus y z. So now this will give us x star. So that will give us x squared equals to x squared plus y squared plus z squared plus yz. And now we come over to the side here. X and y is this bracket. This whole bracket is y. From here, this is x operation y, where y is y star z. So this part here, xy plus x. Remember, okay, this part is squared. So don't forget, because y is squared here. So here will be squared. So x y squared plus z squared plus yz. So if you take a look at it, I'm going to stop here because we're already done with it. So here we have x squared plus y squared plus z squared plus yz squared plus x brackets open, and then you have this expression. So if you compare this to this first part, where's our first one? This one. Here we have x squared, we have z squared, we have z squared here, we have x squared here, here we have z squared. And then if you look at here, xy and xy, if you look at here, yz. So we have a lot of terms that are not similar. Here's y squared, here's x squared. So we have y squared also here, but we have z squared, but we don't have z squared here. We have x squared, we have xy, we have z, but we also have z here, but in this case x is multiplying this bracket, but here z is multiplying this bracket. And here we have z squared, but we have x squared here. So this shows that this is not equal to, okay, let's say since x star y star z is not equal to, x star y star z star is not commutative. Without even going through this proof, you could tell that star is not associative from I and I. So 2 star 3 star 4 give us 453. So 2 star 3 star 4 give us 1447. So the two answers are not the same. So the operation star is not associative, but is commutative. C. Solve the equation 6 star x is equal to 27. Our general rule, x operation y is equal to x squared plus y squared plus xy. So x is 6 and y is x. So 6 star x will give us 6 squared plus x squared plus 6x, that's 27. And this will give us 36 plus x squared plus 6x equals 27. X squared plus 6x plus 36 minus 27 is equal to 0. So x squared plus 6x plus 36 minus 27 gives us plus 9 is equal to 0. And now if you multiply this by this, will give us 9x squared. Factors of 9x squared are plus 3x minus plus 3x. Give us 9x squared plus 3x plus 3x will give us 6x. So x squared plus 3x plus 3x plus 9 is equal to 0. X squared plus 3x and 2x plus 9 is equal to 0. Now x plus 3 plus 2x plus 3 equal to 0. So becomes factor x plus 3 out, x plus 3 and x plus 2 equal to 0. So we say either x plus 2 is equal to 0 or x plus 2 is equal to 0. So x equal to minus 2 or x equal to minus 2. Therefore x equal to minus 2 twice. Binary operation star is defined on sets by A star B equals A complement union B complement. Simplify the following. So operation is A star B equals A complement union B complement. So we have to go for A star A. Okay, for us to proceed with this operation on set, let's refresh our memory on some basic set theorems. First of all, we're going to look at intersection. For intersection, the symbol is this. So it's the A intersection B. What it means that in set A and set B, what are those things that what is in set A that is also in set B? So if set E, let's do it this way. Let's get our universal set. Let's assume our universal set is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 9, 10. And then E is equal to 1, 2, 4, 5. And then let's say B is equal to 3, 4, 5. So A intersection B means what is in A that's also in B. So which means we are looking at common elements. So A intersection B would be the set 2 and 4 and 5. But if we see A union B is different. A union B means what is in A as well as in B. That means we're looking at bringing what the elements in set A that are also in set B, or in both of them together. So A union B means we are bringing two sets together, adding them up together, the elements. So that would be 1, 2, 3, 4, 5. So this is A union B. Now, when we come to this part here, we're given our operation A star B is equal to A complement union B complement. What's the complement to the set? The complement to the set simply means, for instance, complement of A means that elements in set A that are not in the universal set. So elements in set A itself here is 1, 2, 4, 5. So the complement here is that the elements in the universal set that are not contained in set A will constitute the complement. So the ones that are found in the universal set that are not in set A, we may call this A complement, which are 4 and 6, 7, 8, 9, 10. So when you look at it, set A does not have these elements, but they are in the universal set. That's what the complement of this set means. What complement of the set, the elements that will make up that set, you won't find them in set A, but they are in the universal set. So now let's come to what we have here. A star A equals to A union A complement union B complement. So since we have a operation A will replace B here. This will give us A complement union A complement. So from our analogy, A complement union A complement means that if this A complement you join to another A complement, what would it be? A complement union A complement. What would you have? You will still have the same set here, which is 4, 6, 7, 8, 9, 10. We won't have anything different. A complement union A complement means we bring this one together, brings one together, and bring all the elements together. It's a set that contains all the elements in this one and this one together, so that there's no repetition. So this is what you're going to do. And if you look at it, this is the same thing as A complement. So A complement union A complement will give us A complement. So that's A, B. This is A star A complement. Now remember, A here is A complement from our definition. So I will give us A complement union A complement complement. So A complement means that elements in A complement that are not in the universal set. So elements here that are not in the universal set will give us A set A. So this will give us A complement union A. So let's find that. If we are looking at A complement, the complement of A complement, so which means the elements here that are not in the universal set, or elements in the universal set that are not in this set here, that will give us on that set, which is A equals to. So look at the universal set, we have 4, 6, but we have 1, 2, 3 here, so this will give us 1, 2, 3, 4, 6, 7, 8, 9, 10, even 5. So let's see, this set is same thing as set A. So A complement of A complement will give us A set A. So that's how we have A here. Now A complement union A. So if you bring A complement union A, means that the elements in A join to the elements in set A. The elements in set A complement joins to the elements of set A, such that there is no repetition. So union A complement will give us, where's A complement? Is A complement 4, 6, 7, 8, 9, 10, and then what is A? A is 1, 2, 3, 4, 5. So if you join them together, 1, 2, 3, 4, 5, 6, 7, up to 10. What do you think you're going to have? You're going to have nothing but the universal set. So what you're going to have from this, if you combine A complement and A set A, you will get the universal set back. So this will be us universal set C. E. Okay, so now A complements operation A complements operation A. So A complement operation A, so we're going to start first. So following what we have here, E complements, right here is complement, so raised to union E complement as operation E. So this will give us A complement of A complement is E, so that's E, that's of A operation. Complement of A complement will give us E again, so that gives us E union E intersection E. Now A union E is E. So if you bring set E and then you bring set E again and join them together, since union has to do with bringing the elements in both sets together so that there's no repetition. Since one already has 1, 2, 4, 5 and A again 1, 2, 4, 5, so A union A will just be 1, 2, 4, 5. So that will give us A. So that will give us E intersection A operation E again. Now A operation E comes back to what we have here. So E equals to E complement union E complement. And when E complement is brought, is joined to A complement, what you have is you have A complement. That's what you have. So that's C. Same thing as A. A star B is equal to A complement intersection B complement A. So for A star A is equal to, so A will replace B here, so that would be A complement intersection B intersection A complement, because it's A star A, not A star B here, and this A is B here. So now from what we have here, and in intersection, we are talking about commonality. What is common between two sets? So if you look at set A and set B, what do you think is common? It's just 4 and 5. So it's the intersection B is equal to the set for the elements. The set of intersection B has 4 and 5 as elements, because in these two sets 4 and 5 are common. They are common to each other. So now A star A is A intersection A complement intersection A complement. So if we have A complement and we rewrite A complement again, I said let's find the intersection of A complements. Let's get into A complement intersection A complement. What do you think we're going to have? We're simply going to have A complements back. So what will be common to this set that these two sets that have been intersected is A complement. So what I mean is so given that A complement is equal to, if we have like what we have here, 4, 6, 7, 8, 9, 10, and then intersect. Notice intersection. We have the A complements. Same figures 4, 6, 7, 8, 9, 10. So if there's an intersection between this and this, as A complement intersection A complement from set theory, you know that intersection means elements that are found in this set as well as in this set. So what are the elements that are in this set that are also in this set? It's the same A complement. So that's what you will have. So our answer is A complement. B A complements version A complements. So A complements. Remember here, from our rule of combination, A is A complement, but here we have A complement already. So to complement of A complements intersection complements of A complements, which gives us A intersection A. So if A is this, and we have A again like we did here, and then we say set intersect A. What is the intersection of A and E? I will give us E as well. Set E. Right. So what will be common between this set E and another set E with the same elements? It will be A itself. So C E star E E star E star E. This will give us E complement intersection E complement star E. So E complement intersection E complement. That's exactly what we have here. So we have E complement star E. So now this part here will give us E complement intersection E complement. So here will give us E intersection E complement. So what this implies is that this is set A and this is a set of E complements. So between this and this, what elements are in this set as much as in this set? So let's look at it. We have 4 here, and we have 4 here, and then we have 4. So A intersection A intersection E complements from what we have. Let's also have 4 here, since there is already 1, 2, 4, 5, that means it's not supposed to have 4, because we're not supposed to have 4 here, because from what we know about complements, complement is that the complement of the set E is that elements in the universal set that are not in the set E constitute the complement of E. So if set A has 4 and 4 is in the universal set, that means A complement shouldn't have 4. So 4 is not supposed to be here. So from what we have here, if you look at it, A intersection A complement, there is no element in A that you can also find in E complement. So you're going to have an empty set or a disjoint set A intersection E complement equals to disjoint. So this also be disjoint. And then D E, yeah, you understand. A complement star E complement star E complement. So let's work with the bracket first. This will give us E complement intersection E complement star E complement. Okay, so this will give us E intersection E star E complement. A intersection E, let's say E intersection E. So A intersection E is equal to E. Gives us E star E complement. Let this is equal to, from our general way of combination, E is E and E complement is E. So here that will give us E complement intersection E complement. Okay. So it's E complement intersection E. So E complement intersection E. So between E complements here and E, are there elements that are here as much as you can find here? No, there are no elements in E complement and E A set and the set E that are the same. So we don't have common elements. So for that reason, we say this is disjoint or empty set also. The binary operation star is defined on set A star B. Also A complement union B complement. So A star B is equal to A complement union B complement. So if find A star A, so A is A complement union B complement. So from what we have now, we are back to union, and union is if this is A and this is B. So the union of A union B implies A union B implies elements that are found in both A and B. That means elements that are found in both set A and set B. You bring them together, and in that way, even if here has 2 and here also has 2, because there's 2 already in both sets, the 2 counts as 1. So you can have 1, 2. So you don't repeat 2 times. There will be no repetition, even if 2 is here and 2 is here. But you just have to pick elements in both A and B. So in that way, you don't need to bring the elements together. You are joining them together, but you must not repeat the elements 1, 2, 3, 4, 5. While intersection means just common elements that are common to both sets. Because the A intersection B simply means what can you find in set A that you can also find in set B. So if you look at it, 4, 4, 5, 5. So A intersection B will be 4, 5, but the union will be 1, 2, 3, 4, 5. So now we are back to the union operation. So A complement union A complement. So if you have A complement here, 6, 7, 8, 9, 10, and you have another A complement like this case. If you bring them together, A complement union A complement, what do you think you're going to have? If you bring these two sets together and you don't need to repeat the elements, like in this case, they are recurring. This is 4, this is 4, this is 6. So what do? You just have to pick just 1, 4, 6, 7, 8, 9, 10. And what is this? That's the A complement. So this is just A complement B. A complement star A complement. Give us A complement union A complement, complement of A complement. So this is A, complement of A complement is A and union A, and A union A will also be A. C A star A star A also A complement union A complement star A complement is A complement star A is to give us A complement union A complement is A union A complement. So A union A complement. So if you have to get the union of set A and set A complement. So which means elements in A and elements in A complement, to bring them together so that there's no repetition. You're going to have 1, 2, 4, 5, 6, 7, 8. And what would you have at the end of the day? You're going to have universal set. So this could be us universal set D A complement star A complement star A complement. So this will give us A complement union A complement star A complement, and this will give us E union A star A complement. So A union A will give us A that's will give us A star A complement, and this will give us A complement union E complement. So this will give us A complement union E. So this same thing as what we have here. So if you have to bring the sets of A complements, the elements of A complements 6, 7, 8, 9, 10 together with the elements of E, such that there's no repetition. To bring elements together to form is a new set, which is A complement union E. What do you think you're going to have? You're going to have this elements, exactly these elements, and what is the set of these elements? The universal set. So the answer will be the universal set. So here from C and D above, what do you conclude about A star E and A complement star A complement star A complement is the associative, because they are all equal to universal set. So this is from C and D above, we conclude that star is associative. Three elements, same operation. Star is associative.